Hi everyone, it's me, Miss B, and in this video we're looking at the Unit 2 Lesson 14 practice problems from Illustrative Math Algebra 1. So if we zoom in here on this first question, we are going to make note of something first though. We're actually going to make sure that we are showing all of our work. So we're going to show all of our work in order to earn full credit, so can't just select answers. Even if you can do it in your head, still want you to show everything. And I'm going to use a little bit of a different pen color today. I have this bright purple, kind of like it. I might make it a little duller later on, but we're testing out a new color. Just because I don't always like to use black. Black blends in too much with, all of this stuff is already black on the page. So I like to use things that pop out, and the green I was using just wasn't doing it for me. Okay, so first we're going to add two equations. So we want to find the result of that. So let's zoom in here. We're going to take this piece and we're going to add these together. So what do we get when we add straight down? Well, for this first part, we'll have negative 2x plus 3x. So we're just going to combine. And when we do that, we'll actually get that this is just a positive 1x or just x. When we combine our 4y and our negative 10y, that's going to give us negative 6y. And then when we combine the 17 and the negative 3, that's going to give us 14. So we would have x minus 6y is equal to 14. And I see that here is option C. Now we're going to be a little careful because on this next question, and I almost made this mistake earlier, this one is asking us what's the result of subtracting the second equation from the first. So we're going to subtract, and that basically is almost the same thing. Well, if we're subtracting, that's the same thing as adding a negative. So it would be the same thing, and if subtracting helps with that, you can think of it as adding, but everything has its sign changed. Now, I'm actually going to go through and do the subtraction, but you can think of this as, we'll say, or. So you could do this as 4x minus 6y equals 13. And we can do this as plus, but we're going to change all of the signs first. So this will be plus, and then it's going to be, instead of negative 5x, we're going to have positive 5x. And then we'll have negative 2y or minus 2y and equal to negative 5. So these are your options. I do just want to highlight that we have all of our signs changed here on this one when we use add instead. But I'm going to do this the subtraction way. I just wanted to show you that. So 4x minus negative 5x, that's going to be the same as adding it. So 4 minus negative 5, that's a positive 9. So we'll have 9x. Then negative 6y minus 2y would be negative 8y. And then here on the right, we're going to have 13 minus 5. So 13 minus 5 is 8. And so now I'm going to look and find that and see if that's one of my answers. 9x minus 8y equals 8. I do see that in my answer, so that is going to be D as our answer here. So our answer is going to be D. Okay, now question 3 says, solve this system of equations without graphing. So that means I have two options. I can either go for solving this using elimination, which is the process we kind of started learning about today, or I can try to do this with substitution. Now, I'm not actually going to do this with substitution because substitution can be a little difficult, especially if we're moved off of the page there, I'm sorry. Substitution can be a little difficult because we would have to solve one of these and get it equal to just x or equal to just y. But I will demonstrate how this one works for elimination. So what we learned today is that it is still a balanced move to combine two equations together. And building on that, that's where I guess our subtraction part comes from. So I'm going to take both of these and I'm going to add them both together just the way that they are. And my goal is to get one of my variables, either the x or the y, to cancel out completely and make 0 for the coefficient. And that's going to happen when I add them together if, like right here, I can see it's going to happen. Those have the same coefficient, but different signs. So +2 and -2. So let's just add this whole thing together and see what we get. 5x plus 5x, that's going to give us 10x. And this is going to give us +0 because 0y. And 29 plus 41 is going to give us, this looks like 70. Yeah, 70. So that means that in this case, 10x equals 70. So if we divide both sides by 10, that means x is going to be equal to 7. Then I'm going to take this back up, plug it in one of my original equations. So I'll use the one with all the positive. 5x plus 2y equals 29. I'm going to plug in that value for x. So 5 times 7 plus 2y equals 29. So 7 times 5, that's 35. 2y equal to 29. Now we can subtract 35 from both sides. So we'll get 2y because this will cancel out. And then 29 minus 35 is going to be -6. So when we divide both of these by 2, you'll get that y is -3. So then, since I have plenty of space over here, I'm going to write my answer separately as an ordered pair. So 7, comma, -3. And that's how I would solve that without graphing. Now, if substitution's more comfortable for you, you could have done this one with substitution as well, but I highly recommend that you try to go through and do this one the elimination way and see if you can get a little more used to it. Okay, so that's going to bring us then down to number 4. Number 4 here says we have a system of linear equations. So with this system of linear equations, they're asking us, would you rather use subtraction or addition to solve this system? And then I'll zoom out. It says explain your reasoning. So would I rather use subtraction or addition? So let's set up my line underneath here. If I used addition, these are both positive, they both add together. These are both positive, they both add together. And these ones, one is positive and one is negative. So when we add them together, these ones are going to cancel out. And that means my x value, or my x variable, sorry, is going to eliminate. So that would probably work best for me. If I subtracted, that would be the same as changing all of these signs. So we would use 6 minus -6, and that would give us +12. And nothing here would actually cancel out. So I'm going to say for this one, I would rather use addition because then 6x and -6x will eliminate, which would let me solve for y. So I will say that. But I'm going to write it in a bit smaller of a pen. So I would rather use addition because then 6x and -6x will cancel. And I can solve for y. Now, there might be a more mathematical way of saying that, but I feel like this is the conversational way we refer to it. I'd rather use addition because then those two are going to cancel out and I get to solve for y. So that's really just number 4, thinking about whether you'd rather use addition or subtraction. That's going to bring us on to the next page, where we have question 5. So these ones here are not using substitution or anything like that. So if you were working on, your understanding of substitution or elimination, great news. These ones are just going to be some review on the back. So number 5 here, we have matching each equation with the corresponding equation solved for A. So like, how would I undo each of those things to solve it and get A by itself? Okay, so I'm gonna look at two things when I'm starting. So like, let's just look at A here. If I want to get this little a by itself, I'm looking at what am I going to have to do on this side? So what is that operation? And then what's on the right-hand side, because that one is going to undergo that same operation. So in this case, I'm going to have to subtract 2b. And that's it, because then a would be by itself. But I want to do that same operation here in order to keep it balanced. So my result should be, well, if I did minus 2b minus 2b, I would have a is equal to 5 minus 2b. So those are the two things going through my head as I select these. And so I can see with my work here that a is equal to, oh, no, not that one, this one down here, 5 minus 2b. Now, I'm not going to actually show each of these pieces. We're going to work through them a little bit verbally now. Here with A, I would have to divide by 5. So I'm going to look at 2b, and I want a 2b that's divided by 5, and that should be it. Looks to me like that's number 1 over here. So let's match that one up. We'll use blue and match this with number 1. Next up, just looking at what step I have to do, I'm going to subtract 5. So that means 2b should have 5 subtracted from it. And I believe that was the one I almost chose right here because I was drawing my line to the other one. So 2b minus 5. Then my third one here, my steps are going to get complicated. So here we have a couple steps to get a by itself. First things first is we can divide by this 5. And when we divide by both sides, 0 divided by 5 is still just 0. So then I would just have a plus 2b. So if I divide by 5, that goes away. If I divide by 5, it doesn't matter. So I'm going to have a plus 2b is equal to 0. And the only thing I'm going to have left to deal with is just subtracting 2b from both sides. So I really should have a is equal to negative 2b. So I actually will show, oops, I will show my work on this one just so that you can see it, what it would actually work out to. And I know I'm using a different color for this one. I wanted to use red because that's what I was starting with, going red, blue, and purple. So here, if we divide both sides by 5, it's still just 0. And then we would minus 2b. So this would be a plus 2b equals 0. We do that on both sides and have a equals negative 2b. So that means this one here is going to go with number 3. We'll just draw, instead of a straight line, we'll draw a little bit of a thicker line and make it a curve. So that's going to be this one here, number 3, a is equal to negative 2b. So that means our very last one, we're going to do a couple of steps, and because it's not in parentheses, we're going to be subtracting 2b first. It's always easiest to remove the other term to the other side and then divide by whatever the coefficient is for a. So if we have then negative 2b over here, it should then be divided by 5, because those are our two steps in order. Subtract 2b and then divide by 5. So we'll have a is equal to negative 2b over 5, and that is question 2. So we'll draw around this one another curve, just because I don't want to write over top of my work. and these two will match up here. So numbers wise, if you were like, Miss B, I can't tell which one goes with which. Well, good news for you. I'm going to write all the matching ones up here. So A matched with 5, B matched with 1, C matched with 4, D matched with 3, and that means that E matched with 2. So those are all your combinations, all in one spot. Okay, that's going to bring us to question 6. And then question 7, looks like we might have an easier time doing some substitution on those. So I guess I kind of lied. We're going to do some substitution on the back, but that's still a little bit more review, and you might be more familiar with that. For number 6 here, though, we are going to match each equation with the slope and y-intercept of its graph. I do see a couple here that I might want to do first, ones that are already in what looks like slope-intercept form. So that looks like number 3, and it looks like pretty close to this one, although not quite slope-intercept form. So let's match those up first, because I can see that this right here is definitely slope-intercept form. I have mx and plus b, where b is my intercept. So I'm just going to write that form over here just as a reminder to myself that like y equals mx plus b, where m is slope and the y-intercept is 0, comma b. Okay, so based on number 3, my y-intercept should be 1, and my slope should be 5/6. So that looks like D. I have a slope of, or an intercept of 1 and a slope of 5/6. D is going to go with 3, and those ones will match up. I don't need to circle it, actually. I'm just going to write number 3 next to it. Okay. Now this other one, I said it's almost slope-intercept form, and that's because it's not quite in mx plus b format. We actually have mx is this -6x, and then our plus b is a +5. So our slope for this one is going to be -6, and our y-intercept is +5. So this one here is going to go with -6, +5. That looks like B. So I'm going to pick red. -6, +5. And that'll match up here, so B is going to match with 2. Okay, now from here, we can just kind of go in order, but I actually really do like looking at questions 1 through 6 and then matching them with A, B, C, D, E, F, because I think it's easier to find what the slope and the y-intercept should be. So I'm going to do that. For the rest of these, I'm going to work through and just try to identify what the slope and what the y-intercept should actually be for each of them. So we do have some shortcuts for our intercept, and there are some shortcuts for the slope. So slope from standard form, the shortcut here at least. So I'll do slope. I'm going to write that on here. This is a slope shortcut. And this is when it's in standard form. You are going to take the x coefficient, that means the number in front of x. You are going to divide it by the y coefficient. And then you are going to change the sign, either positive to negative or negative to positive. So I do want to explain the reason why I do that, though, because we're going to have to take this 5x and subtract it to the other side. And then once we do that, we're then going to divide by whatever's in front of y. So we're not keeping a positive 5 that's going to get divided by negative 6, it's going to become negative first divided by the negative 6. So if I just took 5 divided by negative 6, I would then want to change the sign because 5 divided by negative 6 would be a negative. I would want to change it to positive because I'd really have two negative numbers here. So that's a bit of a shortcut. If you don't understand it, you can practice putting all of these in slope-intercept form, and that will work as well. So for this, I would say my slope is 5 over 6. One's negative, but then I make the other one negative, so then both of these end up being positive because either negative times a negative or divided by a negative. And for the intercept, that's going to be the constant term, or in this case, the 30. We're going to take the right side, and you're going to divide it by the y coefficient. Because that's what's going to happen to the 30 when I divide everything here by negative 6. So my intercept is going to be 0, and 30, well, we'll start with the 30 divided by negative 6. And so that's going to give me negative 5. So my intercept should be 0, comma, negative 5. That means, for number 1 here, I'm sorry, that was a really long-winded way of explaining it, but it'll make the rest faster. But number 1 here, 5 over 6, and then 0, negative 5, that's going to match up with f, which is down here at the bottom. And so f is going to match up with number 1. But that's going to make the rest of our work quicker. So here I have negative 6 over, nope, not negative 6 over 5. I have positive 5 over a negative 6, but I got to make this now negative, and it's going to turn both of them positive. So my slope is positive 5 over 6. And then for my intercept, we have 6 over negative 6, which means that b becomes negative 1. So number 4 here is going to match up with positive 5 over 6, and b is negative 1. It's going to match with this one right here, which is option E. That's going to match with number 4. So we only have 2 left. Those should match with 5 and 6, so let's just do 5 and 6 here real fast. 6, whoops. I keep wanting to put y first for my shortcut. Like I said, if you can't do the shortcut super great, you can always put them in slope-intercept form yourself. I'm just going a little fast, which is why I'm making some mistakes. It's 5 over 6, but then I need to change the sign on this. So my slope is going to be negative 5 over 6. And then here we would have 6 divided by 6, which means that b is going to be a positive 1. So number 5, slope of negative 5 over 6 and positive 1, that should match up with c. And so c is going to match with number 5. Which means a should match up with number 6 down here, but let's check out number 6 first. So we would have 6 divided by 1, but then I have to change my sign to become negative. But so my slope is going to be negative 6 over 1. And then for my b value, we're going to have 12, and that's going to divide by 1. So that means b is going to be 12. So I'm looking for a slope of negative 6 and an intercept of 12. I definitely see that this one has both of those. So A is going to match with option 6. Option 6. So, and I don't know if that got erased partially, but my number 2 over here is looking, that wasn't even a 2. I think that was 4 that I just didn't fully write. Or I maybe hit undo and part of my 4 got erased, but 4, like that. There we go. Okay, so that's question 6. And then that's going to bring us down to then question 7, where we're going to solve using, in this case, substitution, because we don't have anything lined up where things can eliminate easily, and we probably just want to try substituting some stuff. So I would normally think to myself with my little analogy about a classroom and a teacher, who is the teacher and who's going to be the sub? Well, I see the 2x's by itself over here, and I do see that 2x is actually in the equation above. So I can substitute for that whole thing, this right here of 7y plus 24. So that's what we're going to do. 7y plus 24 is going to replace this whole statement here. So what would that class look like with a sub? Well, instead of that, they'd have 7y plus 24. And then we would still have plus 3y and equals 4. I don't need to keep the parentheses here, so I can drop those. And then I can add my like terms. So 7y plus 3y, that's going to be 10y plus 24 is equal to 4. We're now going to take and subtract 24 from both sides. That's going to give us 10y equals negative 20. And when you divide both sides by 10, you're always dividing by what's in front of your variable, because you want that number to cross out like this. When you divide by that, you'll have just y left over and then have a negative 2. So, oh, I'm not done yet. I can't put a box around that. That's only half my answer. Now I need to go and find the answer for x. So I'm going to come back up here. We're going to use the equation we used originally to do the substituting. So that's 2x equals 7y plus 24. So we're going to plug in negative 2 for y. So 2x is going to stay the same, but 7 times negative 2 plus 24. So 2x, 7 times negative 2 is negative 14. And when we combine those like terms, we'll get 2x is equal to 10. Which means then our last step here, we can take both sides and divide by 2 because we haven't quite solved for x yet, and x is going to be 5. So this means we can write our answer all together as 5 comma negative 2. Negative 2. Started to write at an angle there. And this is now what I can put a box around and call this my answer. 5 comma negative 2. And then the last question here we're going to have is part B. And I also see that this one has kind of a, not really a phrase, but it has an expression that we're going to substitute for because we have the same idea. We have 3y here, and I see that one in the equation above. So instead of that 3y in the equation above, we're going to put 15x minus 21. So we'll have 5x plus 15x minus 21, and that's equal to 23. Okay, now I also don't need the parentheses here because I don't need to multiply by anything. I am substituting for the entire term of 3y. My other option would be that I could divide this part here. I could take this entire second equation and divide everything here by 3. But I just like that the 3y is there. And so we can substitute in for the whole term. So here we're going to have 5x plus 15x. That's going to make 20x minus 21 equal to 23. So let's add 21 to both sides because that will remove the 21 over here. We'll have 20x equals 44. And so that means that x, when we divide both sides here by 20, x is going to give us not quite a nice even number. So It's okay if you do this one as a decimal. Let's just double check. I want to make sure it's not a repeating. Yeah, that's what I thought, but I just wanted to double check myself. When we divide both sides by 20, we'll get that x is equal to 2.2. And it does not repeat, it is just 2.2 and it stops. So that's an okay decimal to use because it's not going to be that bad when we plug it back in. Now, if you get something that's repeating, I would definitely use a fraction for that because when you go to plug that back in, it's going to give you something a little crazy. So from here, I'm going to, I guess, show my work this way maybe and use 3y equals 15. Then instead of x, we're going to put 2.2 and then minus 21. So 2.2, if I multiply that by 15, is going to give me 33. So 3y equals 33 minus 21. So 33 minus 21 is 12. Oops. So 3y is going to equal 12. And last step, divide both sides by 3. You'll get that y is equal to 4. So our whole answer here should be 2.2 comma 4. And there you go. That is this entire assignment tonight because the next page here is actually the next homework assignment. It's from lesson 15. So hopefully my explanations helped. And if you didn't find that they helped a whole lot, I would say definitely make sure you ask your teacher in class because then they can actually answer you in person. And same with me. If I'm your teacher, please ask me in class so that I can answer you in person and address whatever questions you may have. And yeah, thanks for watching.